Okay.
Sword.
All right.
Wow, how much? I don't know.
Well, that's a bad place for it. We signed this anyway. This is Gerber. No, you're gonna have to wait now. We gotta get going. Now I gotta change attendance. All right. Yeah.
It's too silent.
How did you 3D look? 3-1, 3D.
3D is the same as 3C.
3D, no.
Okay, let me see the problem. Which one am I
It's not
doing?
the same as C.
It's completing the square.
Which one?
3D.
4A. Okay, so we're looking at 4A, and what is our task? We're to find, this is a parabola, and we're to find all of the, not all, a list of components there. So vertex, focus, directrix, and focal depth.
4C.
Okay. So here we go. I need to get this thing in a different form. This is standard form. That's okay, but I really don't want it to look like that. So the first thing I think I'm going to do, I think actually what I'm going to do this time is multiply everything by 2, so that I don't have to mess with that fraction. And then now it's a 4, so I'm going to move that 4 over. And then I'm going to complete the square. So half of 16 is 8 squared is 64.
That's some good math.
So there's my perfect square. That's what I have to have right there. So I got it. And then over here I have 2y plus 60. So I'll pull out that y. And now I have my equation exactly the way I like to see it. Where's my vertex?
Vertex, 830.
8, negative 30, yep, so 8, negative 30. And which way do I open? Now, pay attention, it's an x squared, positive, so it opens up, yep. All right, now why do I care about which way it opens? Because that's how I know where to put my focus. So I know my focus is going to be in here. Remember, your parabola always wraps around its focus.
Yeah.
Just a minute, there's some visitor out there.
Someone go up there and
Fuck it up.
put a negative
Put a
out
plus
front.
instead
Put
of
a
that.
negative out front, say she's wrong. Here.
What?
Alright, bro, you have no more, dude.
All right, here we go. So I know my focus is going to be straight up from my vertex, right? Straight up.
I did it a different way and I got a different vertex.
Okay, then you're wrong. Either one of us is wrong, because there's only one vertex, so we'll look at that in a minute. But does anybody see any arithmetic mistakes up here?
No.
All right, I think I'm right.
Yeah.
There's only one vertex, so we all gotta get the same answers. Okay, so I need to go straight up a certain amount. We call that amount P. I'm gonna go straight up. So if I go straight up, this is still gonna be 8 comma something, right? Now, how far am I going up? Well, this number right here is always 4P. So if that number is 4P, then P must be a half. So I'm gonna go up 1/2, which is gonna put me at negative 29.5. If you're comfortable with mixed numbers, that's perfectly okay. And then if I went up 1/2, I'm going to come down 1/2. And so this is gonna be y equals negative 30.5 in terms of mixed numbers. My focal width is 2, which tells me that this parabola is pretty skinny. Pretty skinny. Okay, so did you find your mistake, Alex?
Yeah.
Okay. All right, one more. We'll do one more question. Does anybody have one more from that homework? Remember, you're gonna have a quiz over all this.
4C.
Yeah, 4C.
4C. So now we're doing the same thing we just did, only we're doing it backwards.
What was the focus? Oh,
All right, so I have a focus at 5, 4. That is my focus, not my vertex. And the directrix is y equals 10. Now, that tells me, well, first of all, I'm shooting for an equation that looks like this. So I'm gonna have something squared, a number, and something not squared. That is how my parabola equations look. Well, they can look lots of ways, but that's how we've been using them. So I need to figure out, well, first of all, what do I know? If that's my focus and that's my directrix,
goes down.
I know this thing opens down. And if it opens down, x is squared. Y equals x squared, up and down. And whatever that number ends up being, it is going to be negative, because down is negative. All right, to go on, I really need my vertex. So I need to figure out what my vertex is. Well, where is my vertex? Halfway in between the focus and the directrix, right? Remember, equidistant. So what is halfway in between being up 4 and being up 10?
7.
So this point is 5, 7, which means x minus 5, y minus 7. And then the beauty of this form is, this number right here is 4p, every time. Well, what is p? P is right here. P is how far from my vertex to my focus, so p is 3, which means 4p is 12, and I already made it negative because I am opening it down. Okay. All right, let's get back to our notes. Here we go. Today we're going to talk a little bit about the ellipse. Anybody know what an ellipse looks like? What's the shape of an ellipse?
An oval.
It's an oval. Yep, it's an oval. So today we're going to talk about that. So first of all, let me define ellipse for you. Let's review what's our parabola definition. Parabola is a set of points in a plane, equidistant from a point and a line. That's right. And the points of focus, lines of directrix. Okay. What's an ellipse? Set of points in a plane. These are all plane figures. So it's a set of points in a plane. The sum, S-U-M, the sum of whose distances, so the set of points in a plane, the sum, S-U-M, of whose distances from two fixed points is constant. So what's an ellipse? The set of points in a plane, the sum of whose distances from two fixed points is constant. So in other words, here's our ellipse, here's the center, here are these two fixed points. Those are called the foci of the ellipse. And what the definition means is that if we took any point on the ellipse, I'll just take that one. If this, or this distance and this distance added together, the sum of the distances will be the same no matter where the point is. So if I put the point right here, those red ones add up to be the same number as the purple ones. So if these are both 7, then this one's 9 and 5, something like that. They add up to be the same number. That's what it means in terms of the definition. Now, what does the equation look like? Well, I want to back up a minute. Yesterday, we looked at equations that looked like this. And what did you tell me that was? That's a circle, right? With a center at 1, -1, and a radius of 4. That's what that is. If I took that equation, this is a circle, centered at 1, -1, with a radius of 4. If I took that equation and divided everything by 16, wouldn't you agree this is the same equation? I just wrote it differently. Isn't that the same equation? So this is a circle centered at 1, -1 with a radius of 4. That means that in both the horizontal and the vertical direction, I would count 4 if I were going to graph this thing. So look at problem A, 5A. Doesn't that equation look very similar to this one, except the numbers in the denominator are not the same? Where do you think the center of this thing is? 3, -1. Now remember, when it was a circle, that denominator represented a radius of 4. What do you think this represents?
Width.
A radius of 2 in the x direction. So I'm going to count forward 2 and backward 2, putting me at 1, -1 and 5, -1. So that number is like the radius, except it's only in this direction. And then what do you think that 9 means?
3.
Up and down 3. So this is 3, 2, and this would be 3, -4. Pretty easy. This is the radius squared in the x direction. So the radius in the x direction is 2, and the radius in the y direction is 3. These 4 points are called the vertices of the ellipse. The ones I joined to make the shape, those are called the vertices of the ellipse. All right, let's try the next one. You're going to write the equation of the ellipse. So that's what it's going to look like. So we're going to have something squared plus something squared equal to 1. They're always equal to 1. If they're not equal to 1, you make them equal to 1. You divide to make that happen. But when you're setting them up, you're going to set it up to equal to 1. All right, let's see what we know. We know the vertices are at 1, -7, -6, 1, 1, 9, and 8, 1. are the vertices. Okay? So in other words, if I connect those, and since I didn't use a scale or anything in my pictures, who knows, whopper jive, but those are the vertices. They're the end points of the axes of the ellipse. Does that vocabulary make sense if I talk about this and this being axes of the ellipse? And guess where the axes cross? At the center? So can we figure out the center? Kellen says 1, 1. What do the rest of you think? So I know my numerators are going to be x minus 1, y minus 1. That's how I get a center of 1, 1. Now how am I going to get my denominators?
Find the radius of each of them.
I'm going to figure out how far I went in each direction.
Square.
So this direction, horizontally, I went 7. So under x is gonna be a 49. And vertically, I went 8. So under y is going to be 64. Easy peasy. This axis, you can't tell it from my picture at all, but this axis is longer, right? And that's called the major axis, it's the long one, and this one would be the minor axis. Declan?
Is the right side of the equation always going to be a 1 on the right?
Yes, yes. For hyperbola also. Ellipse and hyperbola, yep. But we're not ready for the hyperbola yet, we have one more. Find the center and vertices of this. Oh man, I have no idea what's on the other side. I hope it's a 0.
That's what I want to ask.
No, it's not a 1.
Oh, what she's done, I'm not gonna
It's a 0.
Is it a 0?
I think I'm gonna make it a 0 and hope it all works out. These kit problems have to be rigged, and I'm sure that was supposed to be a 0. We're gonna hope it's supposed to be a 0. All right. First of all, that's an ellipse. How can you tell, it's obviously not in any kind of standard form, how can you tell that it's not a parabola? What is your clue that it's not a parabola? What? They're both squared. In a parabola, only one will be squared. How can you tell it's not a circle?
X's and Y's have a different factor.
Exactly. The coefficients on x and y squared, the squareds, are different values. If they were both 9s, we'd have a circle. If they were both 4s, we'd have a circle. Since they don't match, we have a warped circle or an ellipse. Now, we need to somehow make that look like this. So we're gonna complete the square twice. So, group your x's and take out a 9. Group your x's and take out a 9. You know that the process of completing the square means adding a number in, so I left a space for that. Now guess what I'm going to do? Group my y's and take out a 4. And then I'm going to move that 23 to the other side. Get it out of the way. And of course, if I have 2 blanks on the left, I'm going to have blanks on the right. All right, so here we go. What are we going to put here? 1. Half of 2 is 1, squared is 1. But be careful, what's going to go on the other side? 9. That 1 isn't really a 1, it's really a 9, because it's in the parentheses. All right, what's going to go here? another 1, and now I'm gonna have a 4 over here. So what square did I create here? This square is gonna be x factor that, what is it, x minus 1 squared? And then this one is y plus 1 squared, and the whole shebang magically, wonderfully equals 36. Why does that make me so happy? Because now I'm gonna divide by 36 to get the 1, and when I divide by 36, everything works out beautifully. So we have x minus 1 squared over 4 plus y plus 1 squared over 9 equal to 1. And there is your equation. Now your job was to find the center and vertices. So where's our center? 1, negative 1. All right, so that's taken care of. Now how are we gonna find our vertices?
Square root the 4 and the 9.
So we're gonna count sideways 2. Sideways 2 will put me at 3, negative 1. Negative 1, negative 1. And then count up and down 9, which puts me at 1, 2. Or up and down 3. Did I say 9? 3. Up and down 3. 1, negative 4. How do those vertices look? Is that okay with everybody? We love the ellipse because it is so easy. All right, so now we're ready to move on to the hyperbola. Do you know what a hyperbola looks like?
No.
Either that,
basketball.
or that,
It's a
or sometimes this,
It's a basketball.
right? That's hyperbola. Now, take a look at the equation, we'll get the definition in a minute, but take a look at the equation in number 6a. What is the only difference? It looks exactly like an ellipse, it looks just like an ellipse, except there's a minus, okay? Definition of a hyperbola. I'm gonna say it fast, and then I'm gonna let you write it, but I want you to listen to it. To set a point in a plane, the difference of whose distances from 2 fixed points is constant. Have you heard that before? Yeah? Only in an ellipse, it was the sum of whose distances, and in a hyperbola, it's the difference of whose distances. And that is reflected in the equation, because the ellipse equation is a sum and the hyperbola equation is a difference. So, recopy for a hyperbola, you recopy exactly what you wrote for an ellipse, except instead of SUM, you write difference. It's a difference. And those 2 fixed points are still called the foci. Everything is the same, except you're subtracting now instead of adding. So effectively, you're taking your ellipse, cutting it in half, and folding it out. So you have curves that look like this. Instead of coming together, they come out. Set of points that are playing the difference of these distances from 2 fixed points
Difference.
is. Declan, did you have your hand up?
Yeah, I was wondering, when it asked us to list, the vertices, does it matter the order?
Nope.
This is for, what does that mean under your clock?
Huh?
The 20 plus C plus M plus B plus 25.
Oh, that's something Father Jeff put up there. It has something to do with 2025.
It's, the three letters stand for the three names of the, three wise men. And it's like a blessing over the door.
Father Jeff comes around and does that at Christmas time, or before we come back from
How
Christmas.
can you reach it?
Ladder.
Step stool. Good point.
Okay, so here we go.
He
So
gets further
sketch it
than
by
that, he
hand.
gets-
So let's start
He gets further than that.
the same way we started the ellipse. Where do you think the center is?
2.
2, -1. Now, if this had been an ellipse, what would this 9 tell you to do?
3 to the right, 3 to the left.
Okay, so let's do that. Only don't take the time to label them, just count over 3 each way, okay? Now, what would that 16 tell me?
Up and down.
Up and down 4, so 1, 2, 3, 4. Now, if it's an ellipse, we would connect those points with our oval, right? It's not. So we're gonna connect those points, but you're gonna connect them with a rectangle. So draw a rectangle through those points. And then draw in the diagonals, and these are gonna be asymptotes, so we will draw them with dashed lines. Draw in the diagonals of that rectangle. So we plotted our 4 points just like it had been an ellipse, okay? But then we boxed it and drew in the diagonals. Now, in a hyperbola, the letter that comes first matters. So x squared minus y squared is a different shape than y squared minus x squared. Whatever letter comes first in the hyperbola is the direction it opens. So since x comes first, remember this point you plotted right here and you do a box through? That becomes a vertex. These are the vertices because that guy opens sideways. And then you can sketch in your hyperbola. So it's like a parabola shape over here, tangent to the box, only it's contained within asymptotes. Parabolas don't have asymptotes, so it's contained in there. So these 2 points are called your vertices. So your vertices, let's see, I counted sideways 3. So this is -1, -1, and 5, -1. Only 2 vertices. These points up here are not part of the hyperbola. We had to plot those though in order to get the box and to get our asymptotes with the right slope. There you go, graph.
So we only do the X ones because like they came first?
Yep, that's the way it opens. All right, so let's take a look at the next one. Okay, it's another sketch by hand. All right, so let's take a look at it. Where is the center of this guy?
This just doesn't.
Cross measurements.
Watch it, where's your center? What, oh, that's a trick, it's a trick, it's a trick.
Oh, shoot. Oh, they're not.
1, -2.
Almost
Why is the center at 1, -2? Because when you write an ordered pair, it's always x comma y. Agreed? What happens, by the way, if you put your center in the wrong place? Everything's wrong. Yeah, you wanna get that center in the right spot. Okay, now what does the 25 tell me to do?
Up and down 5.
So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then the 4 tells me to go 2 and 2. now what? Are you building your box, I hope? And then once you get your box made, are you popping in your asymptotes, which are simply the diagonals of the rectangle? And now, when we draw our curve, since y comes first in the equation, this point and this point become my vertices. And my vertices are, I came up 5, so that's 1, 3, and down 5, 1, negative 7. All right, how do you feel about that, okay? All right, so now get your calculators out. This is what we think it looks like, all right? We think this is what it looks like. Now we're gonna let our calculator graph it. So we learned how to do this yesterday. In order to put it into our calculator, what do we have to do? Get the no, not parametric, get the implicit functions. And that means we get y by itself. So you're going to take your two equation, or your hyperbola equation in B, and you're going to get y by itself. You're going to get two separate equations then. You'll put it in, and hopefully you see what we see. So I added my x thing to the other side. Is that what you did? Now you can do this a couple of different ways. I like to go ahead and times by 25. You don't have to, but you are gonna have to get that over there one way or the other. You can square root right now and then move the 5, or you can move the 25 and then square root. It doesn't matter, it all has to be done. Remember, you're gonna get your two equations, because you're plus or minusing. If you square root it up here, that'll be a 5, I think, yeah.
Can you leave it unvacuumed? Outside square root?
Just leave it just like that. I'm not sure what your question is, but if that's what it looks like, that's fine.
This is worse.
Yeah.
Can we multiply by 100, like the first thing we did?
That's what I did. Like, can we make the common base 100 or whatever?
And then divide by that or divide by 4, actually, it would be, yeah, sure, sure. Yep. Just you gotta get y by itself, so whatever else you do, make sure you're getting y by itself. All right, here we go. positive one in so far. Remember, this is two equations. Now I put the positive one in. When I put the positive one in, I got this.
Yeah, I was gonna say, it just looks really weird.
Hopefully when I put negative one in, I get this. But remember, what we're doing is, we're graphing a thing that's not a function. A hyperbola is not a function. But if we do it a piece at a time, is this a function? Yes. So the implicit functions, again, are the pieces of the problem that are functions. Then when you put them together, you can get what you want, which is not a function.
Yeah, that's one of my moves that too.
Does it all the time, I just powered it off.
You ever run a clear in history?
When did you get it?
Yeah, I didn't get it. Well, I just got rid of it because we're done with this.
So, yeah. So if you're not getting it, you're gonna practice on your own, you're gonna try to put in parentheses and all that stuff. Maybe rewrite the equation like somebody did a different way, that's all fine. All right, D.
That wouldn't be a syntax error. That wouldn't be a syntax error.
Syntax error means you typed it in wrong. That's what that means. So you asked
Or
the
it's in
calculator
like
to do something.
polar mode or something.
Fractions
I'm gonna delete this for you.
All right, here we go, we gotta get this done. Now we're gonna write the equation of a hyperbola. So there it looks, there it is. Write an equation, it looks like that. The transverse axis. Hey guys, pay attention. Play with your calculators. Another time. I erased my picture, but you remember? Okay, so we built this box, and we had our asymptotes, right? When we built the box, we started at the center and counted up and down a certain amount, and sideways a certain amount. These are called the axes of the hyperbola. This one that connected the vertices is called transverse. Trans means across, verse, vertices. So it's across the vertices. This is your transverse axis. If the hyperbola opened sideways, then this would be your transverse axis. It's the one that connects the vertices. All right? So what do I know in problem D? I know that -1, 3 and 5, 3 are the vertices. This is your transverse axis. That means these are the vertices. Your hyperbola looks like that. Now there are, envision the box drawn in there, right? There's these other 2 points that are important too, but they're not the vertices. Okay, what does just this tell me? What does it tell me if I'm opening this way? X comes first in the equation. Remember, it matters. And can I find my center? Won't my center be right smack dab in the middle of that axis? So what is that?
2.
2, 3. The midpoint of -1 and 5. So x minus 2, y minus 3. Okay, I got all that. And then wait a minute, what's this distance? 3? So here I am at the center. If I counted back and forth 3, then doesn't this have to be a 9? Now, the slope of the asymptotes is 4/3. Now remember, if I were actually building the box here, I would start at the center, clearly I'm going sideways 3, but if the asymptotes have a slope of 4/3, aren't I coming up and down 4? Which means under y must be a 16. So again, vocabulary. Here is my hyperbola. This is the transverse axis. Transverse axis. It is the one that connects the vertices.
How would that your calculator do that? Because each one has 2 y values for 1 x value.
You mean how would it graph that equation?
No, how would it just graph one of the curves? Because isn't one of the curves not a function?
Oh, I see what you're saying. If I did implicit functions for this one,
Yeah.
it will graph the positive, when you get your implicit functions, the positive will graph this, and the negative will graph this.
Okay.
So you won't see the entire parabola like you do if it's vertical. You'll see the top half of each side, and then you'll see the bottom half,
Okay, thank you.
okay? All right, part 7. We'll get a little bit of this done, and then we'll be done. The definition of a vector, okay, so remember, unit 4, 80,000 different topics, we're just hitting a few of them here. So now we did our conic section thing, now we're doing a little vector work. What is a vector? You guys in physics, what's a vector?
It's essentially a ray.
Be careful, it's not a ray, because rays don't end, and what do vectors have?
Oh, it's like pointing in a specific direction.
So vectors are, and there are many definitions, but one I like is, a vector is a directed line segment.
I'm gonna actually try.
Now, you remember from geometry that if you had this, that meant line segment A to B, right? But that was exactly the same as this. These are the same. Because if you're talking about a line segment, it doesn't matter if you're starting at A and going to B or starting at B and going to A. With a vector, it is that thing. It's measurable. It has a length. We call it magnitude. It has a magnitude, a length, but it also has a direction. So the vector from A to B, use one tip on the arrow, the vector from A to B is different than the vector from B to A. Now, do they have the same length or magnitude? Yes, but think of it as like, this one's going east and this one's going west. So the directions are different, but the magnitude or length is the same. In a line segment, it doesn't matter which order it is. So the last problem today, we are gonna find the coordinates for the vector that starts at -3, 2, I'll call that point A, and goes to 7, 1, I'll call that point B. So we are finding the coordinates of vector AB. It's so easy. How does this vector move? It goes from -3 to 7. I'm looking at the x's. -3 to 7 is how far? 10. 2 to 1. -1. And there are the coordinates of the, where'd you get that?
From my notes.
Oh, you did go home and get it? You didn't get it from somebody else? Okay, thank you, Tyrell. All right, so A to B, we went from -3 to 7, very simple, that's 10 steps on the number line. And 2 to 1, that is -1, so those are the coordinates of that vector. What would BA be?
-10, 1.
-10, +1. It's the same number of steps, just going in the other direction, right? All right, I'm gonna stop there. We didn't really get far enough to do anything. So your homework is, what, we did 1 through 4, so now you got 5 and 6. 5 and 6. All right, keep it, make sure you have it done, yep. All right. So keep in mind, guys, you gotta keep up with this, because the last day, we're gonna have a kind of a quest over all this stuff.